Hello, hello. How's everyone doing today? Rhetorical question, I guess. We're all doing good. Thank you, Andres, for the great intro. So, in case anyone missed it, my name is Amanda Hinchman-Dominguez. I'm based in Chicago, and this is Kotlin, the next frontier in metaprogramming. If you have been to KotlinConf last year, or at least watched some videos, this talk is based on metaprogramming research that I presented in Amsterdam, and it turns out people were a lot more interested in the project that I mentioned briefly at the end. So, lucky for everyone in the room, we'll be talking about things that are a lot more exciting than academics. User interfaces are becoming increasingly critical to the success of consumer and business applications. So as the need for an application's GUI to create this rich, intuitive, and pleasant user experience, there's this need to generate conversations surrounding the validation and guaranteeing quality assurance for the applications that we create, especially from the user's perspective, which involves actively exploring your environment that tends to be event-driven. Before I became an Android engineer, my intro to Kotlin was through TornadoFX. TornadoFX is a JavaFX framework leveraged in Kotlin, and it was my first love, and it continues to be my favorite framework today. Typically, native desktop development is used for internal applications. It's also used for displaying abstract concepts easily. And in my case, I use native desktop application and leverage the power of Kotlin metaprogramming to write the code that I didn't want to write. Some people might consider that lazy. This project is a project that I created for salespeople to create their own customizable GUIs, which would generate XML, and it would generate JavaScript in turn. And it's kind of a neat project. I was super proud of it until I found out that monkey patching is kind of the lowest form of metaprogramming. Kind of rained on my parade a little bit, but these custom objects require serialization, and I hated serialization, so I ended up creating my own drag-and-drop functionality. Unfortunately, I kind of caught a nasty UI bug while I was trying to micromanage this functionality. The thing about UI bugs is that they're incredibly difficult to detect, they're difficult to diagnose, and they're also difficult to fix. And that's when I realized that I needed to turn to UI testing to be able to validate the behavior that a user might expect. The whole bug thing can be kind of tricky. In some cases, when I talk to developers, I'm like, this is a bug because the application doesn't work the way a user expects it to, and they're like, no, we implemented it exactly this way. So really, it's a feature request. It's a bug. The problem is I didn't know how to write UI tests, so I started asking a bunch of engineers, what makes a good UI test? What makes a bad UI test? And for every person that I asked, I got different frameworks, different philosophies, a lot of I don't knows, and it's pretty tough. And I was like, I don't know how to do this. If I use metaprogramming to help me write code that I don't want to write, is it possible to use metaprogramming to help me figure out how to write UI testing? So, TornadoFX Suite was born, and the purpose of this project is relatively simple. The idea is that you can upload existing TornadoFX projects, and it in turn would analyze the code and detect UI controls that we care about as a user. Users tend to click on buttons, they tend to write in text boxes, so on and so forth. And we can detect these nodes and write simple UI tests for them. If we're talking about UI testing, I thought it would be helpful to take a step back and kind of consider from a philosophical stance what UI testing really is. This is a pyramid of testing that might be expected for an application. I've worked at companies where we've had exclusively end-to-end testing or exclusively unit testing, and you can ask me later what my thoughts are on those experiences. But if you have an application and you're a developer, chances are you have a foundation of unit testing available, and this is considered white box testing. This tests how the system functions, and this is typically done with a knowledge of what's in the code itself. On the flip side of this pyramid is end-to-end testing. This is considered black box testing because as opposed to testing how your system functions, you're testing for the functionality and the behavior of the software itself. Because you don't have any knowledge of what's in the code itself, typically this is done automatically or by hand through, automatically through scripting. UI testing is somewhere in the middle. I like to consider this a bit of a gray area. To kind of look into what this gray area means. A UI test is basically comprised of like really 3 steps. You grab a particular view, you perform an action on that view, and then you check to see if the UI looks as it should. If we had metaprogramming help us write these UI tests, how might we start with trying to grab a particular view? This, I think, was one of the more difficult parts of the project, just trying to figure out where to start. And I looked into a lot of different possible ways that I could look into it. And I was kind of inspired from Jonathan Giles' Scenic View, which is kind of a JavaFX framework which you can configure into existing applications. And when you run your application, it spins up Scenic View, and you're able to grab nodes at runtime. It's an open source project, and I kind of discovered, oh wow, he's using Java agents and good old-fashioned sockets. And it kind of like burned me a little bit in such a way that I finally messaged him. I'm like, hey man, why'd you go with this way? And he just went, I don't know, they're all terrible choices, just go with one and run with it. I followed his advice, and I decided to detect inputs with abstract syntax tree parsing. In particular, I used this library called CastTree. It's a very, very simple, it's a small library, and it's a simple wrapper around the Kotlin compiler. You can take advantage of this wrapper by using the PSI parser within it. And if you're not familiar with PSI, it's an IntelliJ-specific thing that parses syntactic and semantic code models. It's basically the reason why we have syntax highlighting available in our code. Creating an abstract syntax tree parser turned out to be a pretty good decision for me because I was able to surpass challenges that are typically found in statically typed metaprogramming, including access levels. Typically in object-oriented programming, one of the pillars is that you care about whether your fields, methods, and classes are private or public or protected, whatever. And true metaprogramming really doesn't care. So I decided, you know what, I also don't care. And additionally, when we use CastTree, when you create these abstract syntax tree, the potential for these trees to come out they're potentially infinite, both in breadth and depth. And this makes it rather difficult to create intensive recursive parsing systems, especially because with statically typed languages, you care about the casts that you work with. To kind of give a little bit more insight on what I mean by this, I have an evaluation console up just to kind of show how deep these trees can potentially go. And this is not particularly elegant, but I ended up slapping JSON right on top of the CastTree parser. And to be honest, this phase of the project went anywhere from 3 to 5 months. And when I say it wasn't elegant, I mean it was really not an elegant way of going about this. It was a lot of poking and prodding. And over time I'd find out, oh wow, I didn't consider that there might be internal functions and so on and so forth. And it was pretty messy for a while. If I had to do this all over again, I don't think I would have done anything differently. It's impossible to know what the shape of Kotlin looks like underneath the hood. And I think through all this poking and prodding, I have kind of a good idea of how the system works as a shape. And I'm hoping that we'll have a little bit of time at the end and I can kind of go into the code a little bit more, because it is pretty cool. There's just a lot of abstract concepts behind it. Right, so we talked about what's going on underneath the hood. There's a lot going on, but at this point, we only really care about the kind of UI nodes that users interact with. This is an example of TornadoFX code, which, if we have our AST parsing, we know that we are working with a view class. Chances are there's a root within that view class, so you can have these nodes. Just kind of a side thing, I really appreciate how little code TornadoFX is. It's a lot of fun. We can use this intensive recursing system to save the hierarchy of the code, and I decided to go about it with directed graphs. I call them digraphs. Andres is like, is it digraph or dgraph? I'm like, you know what? I don't know. I'm unsure. We can save these nodes recursively, and the thing about this is that while we do have the saved structure, it's not very readable for humans, but it's incredibly easy for computers to understand. We can use a dictionary of nodes that we care about, and this is kind of what it looks like underneath the hood. So for every view that's been detected, there's a UI hierarchy that's saved. But we only pull out the nodes that we actually care about. So out of all the views that we've had, really the only things we care about UI testing at this moment are forms, text fields, and buttons. And I kept it pretty simple and small scoped, but the beautiful thing about this project is that when I'm ready for it, we can definitely add on to this over time. Okay, great. We have the ability to grab particular views with metaprogramming. The next bit, we have to be able to perform an action on that view. This is actually pretty short, but thanks to Kotlin scripting, we're able to generate tests. So if we have a text field, we're probably going to write something in that text field. If we have a button, we're probably going to click on it. Very easy. We just generate that script, and it's not terribly elegant. It's currently a string concatenation, but I'm hoping to turn it into DSLs later on. And for TornadoFX, the particular framework that I went with is called TestFX. It's a pretty slick API that allows you to use robots to stimulate user interactions after setting up the application. And it uses ham crust matchers to be able to grab the nodes and check and verify the states of the nodes. If you're an Android developer, a very similar framework to this is Espresso. Typically, with native desktop development, users tend to not attach IDs to their nodes, generally because they're just internal solutions. People tend to not test the UI portion. So I kind of stumbled onto this discovery that you can actually dynamically insert randomized IDs for detected nodes at runtime. And so this turned into kind of a happy accident for me. Okay, we have nodes, and we can do things with the nodes, and that's where we're at. But the problem is we have this next bit, checking to see, the UI to see if it works, if it looks as it should. This is a bit of a problem. This is a bit of a problem because at this point, we only have the UI nodes that we have. So how are we able to look at nodes and kind of figure out what is it even supposed to look like? What properties does it have? Are there scopes? Are there models attached to the views? I don't know. We got to have metaprogramming figure that out. So this is an example of what the generated testing might look like right up to test text fields. And as you can see, we have the text fields detected. We're able to do something with it, but I added a test at the bottom where we have test button, and we check for the validation of whether a button's enabled or disabled. But we don't have this information currently. This is kind of a demonstration of what the project looks like when it uses TestFX. It's kind of neat. You can run sort of like a sample of your application, and these tests are very simple. They're not terribly smart. What I like about it, though, with this whole metaprogramming project is that I believe it leaves somewhat of a human element with the test. So I think, in my view, the point of automation is not to replace jobs that we're supposed to do. It's supposed to help us enable ourselves to, not focus on simple things like this, and we're able to look at harder problems down the road. Right, so we don't have the ability to check for things like whether a button's enabled or disabled. So how do we know if a node looks as it should? This is the third phase of the project that I'm currently working on. It's not fully formed yet, but the idea that I kept coming back to in my head is this idea of a Tinker Toy machine. Back in college, I saw this picture of, it's a Tinker Toy computer. It was made in 1978. Unfortunately, it's copyright, but I would highly recommend checking it out. It's very cool. It's quite literally a computer with Tinker Toys. And it took a while for me to go past just saying Tinker Toy machines. And the idea that I had was to create a mapping for compositional abstraction for components, which can help define and surround actions for our views. This project, this whole generating UI tests by analyzing code, it's not original. Usually, I think there's like Test AI. There's a couple other frameworks, SmartBear, I think. They're generally done with a lot of teams, and the code bases are ridiculously huge. And typically, the way that we predict our expectations is just a lot of if-else statements, intensive finite state machines. And while there will be an aspect to that, I do believe that creating our own compositional mapping could further and even like simplify the code that's needed to be able to create expectations for our nodes. When a control event is triggered, we can apply binary operations against our states, our Tinker Toy machine, and check against the contract's holistic results of an application representative of the compositional map. I call this abstract compositional contracting. This is a lot of made-up ideas, but I don't know, it seems to be working out so far. To start with, we can start with checking for the state of the node after an interaction. We currently have the ability to locate our UI elements, and within our abstract syntax tree parsing, we can create arbitrary class breakdowns. We have this information right now. The idea that I had is after the initial parsing, we can kind of create like a post-parsing analysis, which can help us create relational mapping that can help us infer what these expected properties are. So looking back again at the whole UI node analysis, I thought it'd be helpful to bring up the actual makeup of what a UI node is. Of course, you have your button, you have the node level, which is associated with it. The node children is typically an identifier for the node. And the two important things that I kind of want to bring attention to is the functional composition and the associated functions. When you create the node within the digraph, these start out pretty empty, but post-parsing analysis can help us fill this in. This is a really, really fun TornadoFX project that I did as a workshop in Chicago for brand new Kotlin and TornadoFX users. It's, I don't know, some babysitter can't keep track of their cat clients. Super fun, but this is kind of a great example to think about associated functions and function composition. Associated functions are functions that are responsible for affecting a node's property or state. So in this particular example, we have our cat scheduler application, and for every client that we click on, we have this cat Avi that pops up, you know, Dr. Cat, Pencil Cat. And we can expect that there's probably some functions that is responsible for this change for this cat Avi. And if we take these assigned values and we look through the code again, This is an example of a bottom view controller. And what AST parsing does for the class breakdown is basically give us this information back. If we take what we have with the UI nodes and the class analysis, we can actually reanalyze what we have. And if we detect the cat Abby within a function, chances are it's probably an associated function. And we can do this with the rest of the classes that we have. Functional composition is a touch different. So as opposed to worrying about what functions affect our nodes, we probably also want to think about what happens when we interact with a node. So if we press the save button, if it was enabled, what functions are spurned from interacting with a particular node? So when we click the save button, we're hitting save, we're hitting update, and when we go through this functional composition and we're creating this digraph, we actually only care about the functions that we wrote. So we're not really going to worry about whether we're adding children or clearing the children. So only functions that we wrote. We have associated functions. We have the functional composition. And then we have this traditional idea of creating finite state machines in regards to models and scope support. If we, finite state machines is kind of a fun concept. We can take a look at another very simple example. We have our cat person editor. If the model of the cat is not dirty, then the button is disabled. If it's been dirtied, it's going to be disabled. So we need to be able to implement that functionality and implement the support for that functionality, which we currently do have, but I'd like to create kind of a Kotlin version of creating this like enum state tracking for states. And what I discovered, I read a lot of academic papers about finite state machines, and the code is generally very, very messy. And what I found with Kotlin is that actually the whole sealed class bit gives us a way to significantly reduce the code and not worry so much about coupled dependencies that may be less than functional. And we have like significantly reduced code with these sealed classes, and we can create these abstract representations of views with the nodes that we care about. Again, this is a part that I'm working on. It's not fully formed. The way I've been going about this project is, okay, I have an idea, I'm going to implement it and take a step back and see how it looks. But I do think I'm onto something here. The idea of formally specifying your UIs through metaprogramming actually gives us a couple benefits. So implicitly, we clearly express ourselves, which leads to a better understanding of the system. More importantly, metaprogramming has a pretty good understanding of that system. And more explicitly, we can use these formal specifications to check the properties. So does the UI have any dead ends? Are there certain permutations of interactions that might end up causing us to lock it out? Hard to say until, I guess, we have that post-parsing analysis complete. That is kind of where that's where I'm currently at in this project. And there are some promising discoveries with the metaprogramming research that I've done thus far. There's this idea of a metaprogramming locator mechanism, which is essentially this intensive AST recursing and creating these like digraph relations. That's what I call the metaprogramming locator mechanism. There are other existing locator mechanisms, typically done with AI and machine learning, in particular image classification. And what I found with current existing AI locator mechanisms is that they're very, very intensive, and they do suffer in accuracy, especially when it comes from, if you look at an Android project and you're looking at a view and something is partially covered, there is a far less likelihood that we're able to detect that UI node. And furthermore, if you have custom interactions, say you have a text field that's clickable, chances are your AI image classification is not going to detect that. That is definitely one huge leg up that metaprogramming might have on current AI locator mechanisms. The other bit is that Kotlin metaprogramming gives us this ability to further analyze relationships of UI hierarchies, functional compositions, and generated test results. I did look into machine learning for quite a bit and spent a good amount of time looking into it because down the road, I do have some exciting plans for this project. And I was hoping that, as I've explained, current test generation is very, very dumb. If you watch Silicon Valley, there's kind of this funny bit about this hot dog, not hot dog app. You scan a hot dog, and it gives you hot dog, and it's like, okay, great, let's look at other food. And you scan pizza, and it's like, not hot dog. I feel like this is very much what this project currently is. But it's very dumb, but the core tech is valid, and I do think it needs to be trained. So that's why I started looking into metaprogramming. Not metaprogramming, machine learning, because I do believe that metaprogramming is a natural progression to machine learning. But what I've found in my research is that, coincidentally, machine learning is very dumb. It's not very, very smart. And traditional models of machine learning will not be sufficient for creating analysis and deciding what makes smarter testing. That's why I was really excited about this third phase for creating these metaprogramming relational analysis. I think the idea that traditional machine learning currently only offers extrinsic rewards. So I don't know, if you think about, complex video games where if you make friends with someone now and you betray someone later, that's not an immediate reward. You're not going to see the immediate reward until later in the game. Obviously, the underlying structure of that is intensive finite state machines. But if we draw that parallel to machine learning, it just doesn't have the idea to do that. So I started looking into curiosity-driven learning. It's theoretical, but what I found with that is currently, I think tensors are not able to feed a lot of information into it, and I think this idea of metaprogramming, drawing out and creating this analysis for generating relation analysis actually could take some of that load off traditional models of machine learning. There's a lot of potential. Oh, and also, since we have all this functional composition and analysis, there is potential in the future to add a feature on for creating unit testing for controllers, so that would be really exciting. Right, okay, future plans for TornadoFX. I'm excited to say that this project is open source. I would love folks to start taking a look at it if they wish. There's a lot more to do with this project. I spent a lot of time trying to solidify what I currently have. Part of it would be creating DSLs for flexible test building. It's currently string concatenation, not very elegant. No worries. Oh, thank you so much. Also, I'd like to create DSLs for abstract compositional mapping. Creating this idea of just creating flexible code will allow us to analyze this later on. The AST Parser, it's sitting in the project right now, but I have started pulling out TornadoFX specific configurations. Eventually, I would like to have this project opened up in a way that maybe we can start looking at Android code as well, and eventually pull AST parsing into an independent library for folks to take a look at their own projects and see what it looks like underneath the hood. Oh yeah, I already mentioned the UI frameworks. And last but not least, if I'm able to open this up to multiple projects other than just TornadoFX, down the road, I'd like to have users volunteer data if they wish. I don't know, there's not too much personal data, so I think this is a ethically safe thing to do if they want to do it. In terms of deep learning, what I'd like to see is we generate these tests. Do those generated tests pass? Do they fail? What's the commonality of some of those failing tests? Is it possible for us to learn what UI hierarchies are just way too complex and they tend to just create failing tests right off the bat? Some people have given me really interesting recommendations on data I could collect, maybe like the ratio of negative and positive space. And I do realize that this project kind of has this intense crossover kind of into this whole quality assurance QAing thing. But I think it's really important for developers to start looking into the idea of testing in terms of verifying that the software that we create from a user's perspective is intuitive, because we have this language that we use for Kotlin, or not just Kotlin, but any language that we use to create these systems. And if they're incredibly complex in hierarchy, I can't help but feel like it's just going to kind of transfer over to the products that we create. Personally, I've worked at companies that have had over-intensive and over-complex not UI systems, but just like general systems, whether it's with searches, whether it's with UIs. And I find that if we have to constantly coach people how to use the product, it's probably existing in the code as well. I think there is a relation between the code that we write and the products that people use. And it's very easy to remove ourselves from the user and the product itself and the problem that we're trying to solve. But it's all connected. I always think about, that one It's Always Sunny episode where Charlie's like, Sylvia Plath, it's all connected. It is all connected. These are some relevant links. If you're interested in looking at TornadoFX Suite, currently I have a branch open called Mapping Nodes. That is what I'm currently working on, and eventually I'm going to have that merged in. I do have one other contributor, and when I get home, I'm going to look into the pull request he had for CI/CD. I don't even know what he's using. I haven't checked the pull request yet. Also, I have had an extensive amount of research between automata and UI and formally specifying your UI. I've looked into the data science research, which of course, realistically, if I keep going at the pace I'm going at, and if people want to contribute, this might be more relevant in a year or so. This project is constantly evolving. It's never not. Literally by the day, there's just exciting new developments. And of course, the bottom two are the two TornadoFX applications that you've seen. If you're interested in TornadoFX, or if you work on a JavaFX framework, I would highly recommend looking into it. There's a lot of great documentation. It's literally my favorite sub-community in Kotlin. Literally, you could ask the dumbest possible question and 3 people will answer it. So definitely check us out on the TornadoFX channel. And oh yeah, if you want to follow me on Twitter or Medium, I do write a lot. Or you could follow me and look at the little elevator fiasco that I had yesterday. I got stuck in an elevator and I just panicked. But it wasn't for too long. The staff was great. They rescued me from a dark elevator. Everything was everywhere. But yeah, that's pretty much it for now. I'd love to open up the floor to questions, and we can also look into the code itself. Maybe it'd be helpful to start with that, and we can do questions shortly after. This is the mapping UI nodes that I briefly mentioned. This project really looked like a mess, and it really wasn't ready for other people to look at for a while. I wanted to send Jake Wharton this project, but I was just too scared. And I think it's almost ready now. So to give there are a lot of abstract concepts and diagrams, but I think we can kind of bring these ideas together looking at the code. We have, from our AST parsing, we have the class breakdowns, we have the properties and the methods that are associated with it, and the test class info is what's responsible for generating the tests themselves. We actually have different kinds of digraphs. There's 2 existing ones. We have the view hierarchy, which saves nodes, and I'm not not sure where that other one went. Oh, it's sitting in the node class. Yeah, so we have the sealed class for nodes, and there's two different types of nodes. You have your function composition, and you have the nodes right in here. And kind of the nice thing about this digraph structure, I made some interesting choices in this project, and you can tell me if I'm wrong or not, but typically I feel like for this kind of case, it would probably have been more appropriate to implement an interface, but that just would have been a ton of code, and I just went with the abstract because a lot of the functionality is the same. And then, of course, in the respective function and UI node digraphs, we'd get different functionality here, and that's why I went with an abstract class. And so I was like just kind of happy that I was able to reuse this graph, kind of get it for free. Just kind of some cool underworking or underlying work with what the structure looks like that we're trying to parse for. The AST parsing system itself, still kind of a mess. Like I said, it's going to get stronger as we scan more. Frankly, this is kind of like what the AST parser looks like between this node, decal, and func. I'll be totally honest with all of you. The top part of the AST parser, I'm really, really scared to touch it, so I haven't. But as you get deeper into the whole class method breakdown, this is where JSON gets applied, and it's rather nice because we're able to have this intensive recursive structure. We have blocks, declarations. Within, you have statements, more declarations, declaration properties. You have expressions, elements, parameters, values, and it's a lot of processing power. I haven't even looked into this aspect yet. I just sent it to the back thread. I'm worrying about it some other time. Kotlin extensions, extension functions are amazing. This is what allowed me to clean up my code significantly. Huge fan of it. I wasn't sure how I felt about it at first, but it is really great because like I mentioned before, I have started pulling out TornadoFX specific configurations, but I can still use the KParser class itself, and I can keep that stuff independent. It's actually not totally done yet because I'm still trying to figure out how to work with sealed classes and inserting them as parameters. I think that's mostly what I wanted to share. I'd be happy to open up the floor to questions.
Hey, Amanda. Thanks for the talk. It was amazing. It
Thank
was
you.
really interesting for me because we in the Arrow team are also facing some of the problems you mentioned here about parsing the AST out from the PSI and everything. And I was wondering why you've picked an approach like the one you're using, which is using CastTree and for parsing out the AST and everything. Given that TornadoFX seems to work over the JVM, isn't it?
Yes,
Okay.
this project is exclusively done with the JVM. I've kind of stayed away from the whole native bit. I'm not terribly an expert on this, but to answer the first part of your question, I'm really glad you asked it, and I certainly hope I can word my thought process because it was a real jumble and a real mess. I've considered different things for analyzing the code. PSI parsing is pretty beneficial, I believe, for even like runtime. I thought about analyzing code at runtime, but using an AST parser, I feel like actually creates this truer definition of true metaprogramming. So true metaprogramming does, like thinking about Ruby or Haskell, other purely functional languages, you're able to analyze your code at runtime and even create more code. And there's some restrictions that are typically done with any language that runs on the JVM. One of those issues being that the whole idea of using the JVM is that the code needs to compile. So my worry was that if I analyzed the code at runtime and generated more code, we don't have that safety of the compiling for type checking. So that's one thing that I did worry about. And also there are other issues with the JVM. I mean, really, Kotlin is just a language that's a workaround for all the issues in JVM. You know, we can think about reified generics. So the JVM has type erasure, which is why Kotlin created this really cool reified generic system where they preserve the generics within the bytecode itself. Again, there's like all this workaround for it, and I figured that being able to analyze the code, so you have TornadoFX running on the JVM, and then you're just reading the code, so it's literally just text reading as opposed to something smarter, like trying to do it at runtime. And we don't have to worry about issues like type erasure. I think the idea of being able to analyze external code without even knowing what it could be before compile time, I think just demonstrates stronger metaprogramming capabilities that Kotlin has as a language.
And did you consider using capt for compile time metaprogramming?
No, I played with it for a time, and unfortunately, I can't remember what stopped me from using it at some point. I tried so many different things. I've tried capt. I think unfortunately, I don't remember what stopped me from it. But I had considered using it, and I just can't remember for the life of me what stopped me.
In our case, I mean, it was like the other way around. We started using capt because that was kind of the most obvious solution.
Yeah,
Since
it was
we are coming from Android and, you know, worlds where we use capt a lot for running annotation processors and so on. And at some point, we have realized that it's not supporting multi-platform because it's using a lot of stuff of the Java reflection APIs under the hood. So it's totally JVM dependent. So we are actually trying to move out from capt to something more similar to what you did here.
Yeah, that is kind of an interesting point to bring up. Right, annotation processing. I think that is why I started looking into CastTree in the first place. What actually stopped me short, the specific thing that I hit as a wall, now I do remember, is one thing I really hated about annotations was the fact that I couldn't dynamically insert variables within annotations, and that's kind of what stopped me short. Actually, I was talking about this with Kevin Most last year at KotlinConf before his talk, and he's like, actually, I can do it. I'm like, no, you can't. What are you talking about? He's like, no, I rewrote the grader compiler, so now I can. I'm like, okay, that's wild. Yeah, annotation processing. What I've found in my metaprogramming research, which anyone's welcome to reference later on, either in Medium or on YouTube. What I've found with annotation processing is, aside from the fact that you can't dynamically insert whatever variables or annotations or elements within those variables that you can have, I think there's also restrictions on when you can use it. For annotation processing, you have to designate in Java when you're using it at source time, compile time, and there's some other third option. And to be honest, I didn't like the idea that I had to pre-configure all those things before, and I think it would have greatly complicated the scope of this project. So I think those were the things that kind of stopped me from using KATP.
Okay, thanks.
Thank you. I know there was a whole lot of information, and I appreciate all of you riding this roller coaster ride with me.
Hey, during your talk you mentioned that you found a way to generate IDs at runtime for your different nodes.
Yes.
And I would be really interested how you did that, and is it consistent across multiple application runs?
Theoretically, yeah. Let's see. Actually, we can do this thing where live demos are generally not recommended. Also, a fun side fact, I had to change computers for work, and Oracle does not allow JDK 8 to be downloaded for free anymore, so I had to switch to OpenJFX in JDK, and that was also right in itself. And we're going to generate those tests, and if we pull up this other application here, this is the test I mentioned earlier, and this is the generated test that we have. And it's somewhat similar. It's complaining that there's, redeclarations. But this is the part that I wanted folks to look at for this randomly generated node. I also have an article on Medium that expands into this. So from the detected UI controls that we have, you can create random generation. I actually have to edit this a bit because I looked at this and I'm like, I don't think I like this. It's not terribly useful because then we have like these names and it just looks crazy. But yeah, so you can create randomly generated IDs. Let's see. All right, you guys get to look at an ugly part of my code. I'm very excited for this. Oh, also, this is also not elegant, but I do have a logging system for the class analysis that we do have. It's pretty cool. Feel free to try it out yourself. So at the bottom, we have this random string generator, which would be responsible for inserting that within, like, creating these string concatenations. Not proud of this at all. Yeah. But anyway, you can create these random strings, and I use like a data class to basically classify what these things are. And then I read somewhere that we should try avoid using late init vars, but I find with event-driven applications, it's kind of hard to avoid. I try to stay away from it, but sometimes it's hard. And so once you're able to do that, kind of a neat thing with TestFX is that you're able to set up the application before it runs. So it's like you're not running the actual application. You can create your own independent setup. And so in this setup, what we're actually doing is creating an empty view, and we're slapping the view that we're testing specifically. So it's not the actual application itself. So you're setting it up at runtime, and then at this point, since we've already randomly generated the IDs, we can attach those IDs, let's see, right here. Add all IDs to descendants, and then checking to attach the node ID. So there's some difficulties with the Java FX framework, but there is a way to do it, especially if you're already familiar with the node hierarchy that you're working with. I hope that answered that question.
It does, thank you.
Awesome. We're killing this. Any other questions? I'm ready for them.
Hey, does this framework work with headless tests? Can I run it on a CI, for example? Headless, running with CI. That is what I'm hoping that we'll be doing. Actually, I can pull this up. There is currently one other contributor on the projects, and he did he has a pull request right now for CI/CD. I don't even know what it is. So theoretically, yes, it just doesn't exist yet. And it's something that I promised I was going to look at once I got back home. Thank you.
Yes. Are there any other questions? If not, thank you everyone for coming to this talk. Feel free to talk to me after, whether it's about TornadoFX or this project or, I don't know, anything in particular, Chicago life, I don't know. But definitely talk to me about TornadoFX because I'm a huge fan and I would love you all also to become fans of TornadoFX. It's, fun fact, Thomas Neild, he uses TornadoFX in a lot of his talks on mathematical modeling to display his concepts for regression testing and optimization. There are also lots of other uses. People have started coming to me about projects they've done, even like nonprofit organizations for crunching numbers for crime in the US. It's been really cool to see people use native desktop applications for a wide array of things, and a lot of it's basically just like coding for the better of humanity, and I'm a huge fan of that. Well, thank you very much, everyone.